Hello and welcome to the channel for today's topic and video. Today's video is about rate of the reaction and chemical kinetics, guys. Yes, it's very important topic for most of the national and international curricula like IGCSE, IB, AP, Excel, and also very important at junior college KS3 and KS4 key stage levels. Now let's see what are the things we are going to discuss in today's topic. So what is a slow and a fast reaction, and we'll talk about rate is a speed, reaction rate in real life, reaction rate in important fields like medicine, astronomy, and finally, how to calculate the rate of the reaction, exam style questions. Alright, so let's quickly talk about what is rate, guys. So rate, simply put, is speed. So like everything in our world has a speed. For example, a racing car, a cyclist, a person traveling from point A to point B. Similarly, whatever happens in our world happens in chemistry. So in chemistry, when we do reactions in lab, each reaction has its own speed, its own pace, and that particular speed is called rate in chemical terms. Now, it's very simple, guys. Some reactions are very slow and some reactions are very fast. But it's always good to measure the rate of reactions with an optimum speed, which is not very slow, which is not very fast. Later on in this video, we will see why it is important. Now, activity time. So quickly on your screen here, you have two reactions shown. Reaction A is rusting of an iron hammer, and reaction B is a firecracker. So all you need to do is think and tell me which of the two reactions is fast. Were you able to answer it? Yes, B, the firecracker, is a combustion reaction and is really fast as compared to rusting of iron. Rusting of iron, all of us know, sometimes it takes days, weeks, months, and also years, guys. So it's a very slow. So reaction A is very slow and reaction B is very fast, combustion reaction. Now, as I said, chemistry in daily life. Chemistry is everywhere, guys. So in daily life, what are the scenarios where rate becomes important? So number one is in medicine. So in medicine, guys, let's take an example of a simple painkiller. So a very popular painkiller becomes popular. Why? Because when an average person takes a painkiller for headache, the headache is relieved approximately in an hour's time or half an hour's time. Now, why this particular painkiller is more popular? Very simple reason, because the other competitors, maybe they are having the same effect, but they are taking more time. The more reaction time, the less later relief. So you understand, right? How the reaction time of a medicine or drug is very important in medicinal chemistry. Similarly, in emergency situations, guys, when a person has an attack, anaphylactic reaction or something, and is rushed to an hospital, the very first thing that a doctor does is gives the emergency or first aid medicine, depending on the prescription and the doctor's criteria. Doctor knows the best. So that particular emergency medicine has to react in a certain amount of time window, 15 minutes or 20 minutes, to save the life of that person. So now you understand how important and crucial the speed of the reaction in medicinal chemistries. Let's see another example, guys. In astrophysics or space science, when we launch space missions, rockets, spacecrafts, it's very important that the space scientist measures the rate of combustion of fuel put in the rocket properly. Fuel can be liquid oxygen, liquid hydrogen, but why it is important to calculate the rate of fuel? Because that particular mission should reach the target planet with the total capacity of the fuel put. Imagine if it's not calculated properly or if it's calculated incorrectly, what will happen, guys? The mission may not reach the required destination. So you understand how important the rate of the reaction is in space chemistry. So that's why chemistry, one of the important fields we study is kinetics. Now, coming back to the exam style questioning and all that, let's first quickly see the mathematical aspect. How do we calculate rates? So there are two simple ways, guys. Either we can calculate the decrease in the concentration or amount of reactant, or we can calculate the increase in the concentration of product. Let's take an example reaction here. 2A plus B gives C. Now, in this reaction, as the reaction proceeds, the concentration of reactants decreases, A and B, and the concentration of product, C, increases. So, one formula or way is we can calculate rate in terms of A. So, what will be the formula? The formula will be rate is equals minus 1 over 2 change in the amount of A over change in time. Now, you may ask why 1 over 2? Because there is a 2 in the balancing or the stoichiometry of A in the reaction. So this is very important, guys. When you're writing the rate formula, the coefficient of balancing goes down in the rate formula as denominator. Point number one. Point number two, if you are writing it for a reactant, in this case say A or B, then a minus sign is included in the formula. Why? Because the reactant concentration decreases. So that change is negative and negative cancels and the rate becomes positive. So this is very important to put a minus sign for reactant. But the same reaction we can calculate the rate in terms of C. So in terms of C, the formula will be a bit different. It will be rate is equals change in the amount or concentration of C over change in time. Alright, now let's apply this formula in an exam style question. So here's a question, a particle diagram question given, guys. For the same reaction we discussed, 2A plus B gives C. There are three different setups shown. The setup at 0 second only has A and B. Setup at 5 seconds, it has all three A, B and C. And the setup at 10 seconds, all the A and B are over and we only have the product C. So how can we calculate the rate in this case? So let's do an example here. Let's calculate the rate for the reaction at time interval 5 seconds. So we will calculate by both. We will calculate by A, the reactant. We will then calculate by C, the product, and we will see what is the value of rate we get. Do we get it same? Do we get it different? Let's check it out, guys. So let's quickly calculate for A here. So if you count from 0 to 5 seconds, we only have 4 A's used up. So initially at 0 we had 6 moles of A. Consider each circle as 1 mole for a reference scale. And now at 5 seconds we only have 2 moles. So change in concentration of A will be 2 minus 6. So that's minus 4. And we also have a minus in the formula. Remember, it's a reactant. Over 2 times change in time. Change in time will be 5 because 5 minus 0 seconds is 5. So 4 over 5, we will get 4 over 10, my bad. 4 over 10, because 2 times 5 is 10. We will get 0.4 moles per second. So that's the rate in terms of A. The two minuses get cancelled, guys. As I told you, rate is never negative. Rate is always positive. Remember that. Rate is always, yes, positive. Alright, now let's calculate the rate in terms of C. So if you see C here, in 5 seconds, we have 2 moles of C. And at 0 second setup, we don't have any C. So 2 minus 0 for change in the amount of C over change in time is 5. So now we get 0.4 mole per second. You see, guys, with C also when we calculate, the rate is same, 0.4. For A also, it's 0.4. That means whatever you use a reactant amount, you use a product amount, rate will remain same. I always give an example of people traveling in a single car. If two friends A and B are traveling in the same car on the highway, what will be the speed of A? That will be the speed of car. Correct, 120 km per hour, for example. What will be the speed of B? Also 120 km per hour. right? Because we are traveling in the same thing. So a reaction can be considered like a car. So all reactants and products are traveling together. That's why the rates cannot be different. Alright guys, now we have test your knowledge. So let's have this question here. I'll just adjust my mic. Alright, so if you see the question here, the question says calculate the average rate of below reaction from the given data. And you see this is a reaction example taken from IGCSE Conceptual Chemistry. That's the book I authored guys for Cambridge Chemistry in 2016. So the book is available on Amazon. You can refer it for your basic chemistry uh, studies. All right. So in this particular reaction, guys, we have time given in seconds. Mass of copper deposited is in milligrams. So this is very important to note, guys. The amount can be given in any unit. It can be grams, milligrams, kilograms, moles, liters. Sometimes if it's a gas, they can also give dm cubes or liters of the gas. So in that case, the unit will become liter per second. In this case, we will get milligram per second. Depending on the amount, guys, the unit of the rate can change. It's always amount over time. Now, so how can we calculate the average rate here? So it's very simple. We take the total change in concentration. So from 0 to 30 is 30, 30 minus 0. And the total change in time, which is 10 minus 0. So 30 over 10, we get 3 milligram per second. Similarly, guys, they can ask you instantaneous rate, which is at particular instant. For example, what's the rate at, okay, you can try this on your own. What is the rate of the reaction for time 4 seconds? So you have to calculate that. Take the amount from 0 to 15 because that's the amount for 4, and then divide it over time, which is 4. So that way you can get the rate will be then divided over time, which is 4. So that way you can get the rate will be around 3. So you will notice that the rate, guys, decreases from 3.25 was at 4 seconds, but now the average is just 3 milligram per second. So why? We're going to answer this question in our next videos. But let's go to the next point for today. And that is the another question for practice. So you guys try this question. If you need the PowerPoint for this topic, if you're aspiring or a new teacher, you need this PowerPoint, the one I presented in this video. Below is the link of the test where you can get this PowerPoint also. Also, if you're a student who is practicing this topic at your own without any help, you need a practice worksheet or resource. Below is the link for a test for downloading the practice worksheet. I would love to answer if any of your doubts or questions related to this video. Please put them in the comments. Do not forget to subscribe and like our channel for the next video, which is going to be on order of the reaction and types of orders, first order, second order, and so on. See you guys. Have a good time.